Hi everyone, thanks to be here. Thanks to the PyCon team from Colombia to accept this presentation that has some of our last results about cybersecurity and data science. This presentation is divided in two parts. The first one is going to be presented by me. My name is Urcuqui. I am going to show you some of our applications of data science and cybersecurity. And the second part is going to be introduced by Jhoan Delgado, who is going to show you some of his research results about adversarial machine learning. I would like to start with a brief introduction. As you know, artificial intelligence theory, right now we have its applications in our daily life. For example, we can mention some systems, Netflix and Spotify, that use, for example, recommendation systems based on machine learning that is a sub-area of an artificial intelligence that I am going to introduce in the next slides. But I would like to mention, for example, the other part of the things. For example, the data and the data and the use of artificial intelligence for not good things. Cambridge Analytica is one of the situations that was presented some years ago of the use of surveillance systems and the data to make decisions about us, especially for the elections in US. On the other hand, we have another cases that are more for not real situations. For example, in the movies that show for the robots that are going to destroy the human being. Well, the IEEE Computer Society showed in some of its reports the relationship between the cybersecurity and data science for this year. I would like only to mention the item 8 that shows some of the sub areas of the machine learning that I think is interested right now. In the right side, we can see, for example, the same thing in the Gartner presentation for 2020. Explainable AI is on the top of the hill of the innovations, and it is one of the areas that I right now is working in different companies and in the academy. Well, the software systems, especially in cybersecurity, are based in two methods. The first one is signature methods, and the second one, anomaly detection methods. They are based on the data of the past. Let's suppose a researcher that wants to define if a software is benign or not. So if using some techniques that I am going to mention, for example, static analysis, he or she can define if the software is malware or not. If the result, for example, is a malware, this software is well, a signature is going to make from it, and is going to be in a database that we are going to download for our anti-malware systems. Machine learning in cybersecurity has been explored for the last years. I would like to cite, for example, this paper that mentions that conventional security software requires a lot of human effort to identify threats, extract the characteristics from it, and encode them into software to detect them. Our machine learning is based on the data and the patterns from it, and we can resolve some of the problems in a short time. We can see right now in our daily life different products that integrate cybersecurity and data science for different things. In the second graphic, in the right part of this slide, you can see, for example, different things. We can see anti-fraud, and identity management, anomaly detection, mobile security, well, different products. But I would like to mention one special report that was made and shows how the use of cybersecurity and artificial intelligence is going to increase in the next years. Some of their applications are based to create solutions to monitor, predict, detect, and finally resolve and prevent. We can see right now its uses. For example, we can mention authentication that are based on bioinformation. Using natural language processing from the emails in order to detect phishing attacks. Moreover, we can mention the use of the data and machine learning to manage the vulnerabilities of the systems, using, for example, the data of our network systems. And the artificial intelligence versus artificial intelligence, that is a topic that Jhoan Steven is going to explain in his presentation. Well, we are right now according to the analytic value escalator from Gartner, and in the use of the data, and the idea is to apply machine learning in order to answer this kind of question: what will happen, or how can make it happen according in the cybersecurity problems. Well, Andrew Ng mentions that it is difficult to think of a major industry that AI will not transform. And that is the same thing that has been happening in the cybersecurity. Artificial intelligence has different sub areas that are bio-inspired. But I am going only to mention machine learning. That is one of the sub areas that are right now important, because we have the infrastructure systems and the data to make the models that are based on machine learning algorithms. Well, artificial intelligence, or sorry, machine learning looks for a system with the capacities to learn in various environments without being explicitly programmed. One of the important things here, as I mentioned previously, is the input, and it is the data. We can have different algorithms that can be complex or not. For example, we can use decision tree algorithms. We can use neural networks. We can see others, for example, Naive-based. But the idea that these algorithms are going to take the pattern of our data and will make a model that represents it. In order to train these machine learning models, three approaches exist. I would like to introduce them and show you some of our research results during these years. For example, supervised learning. In 2014, we started in a project that explored machine learning classifiers to identify Android malware. We started with a coding a Python algorithm that uses some libraries that get the information of specifically the permissions from a set of malware and another set of benign applications for Android. The idea was to understand what the pattern is from the permissions and if it exists a difference between them. So in supervised learning, we ignore the objective variable. We know what we want to what we want from the machine learning model, specifically the output, and we ignore the output relationship is and the dependent variables. According to this research result, we propose different machine learning classifiers that can predict when a APK, that is an application from Android, can be or not a malware. Unsupervised learning is another approach that are based on that a scientist or a researcher, or a programmer, doesn't know what is the output of the model. The idea is to understand what is the pattern of the data. One example that we explored some years ago was the idea was to make some models that allowed us to detect when anomaly exists in a network. We explored some information, specifically logs from different proxies from a company. The idea was to make a document of words from them. And the idea was to make a dictionary of words generated by the proxies or the network. More specific, to make a dictionary that represents the language of the network. Using it, we can identify any anomaly in the communication that include strange words. A reinforcement learning approach. We have an agent that it is going to learn by the interactions that it takes from a set of actions and rewards that it will get from a function and an environment that it is maybe artificial. Well, for digital threat detection, as I mentioned previously, one important thing is the use of the data. We can mention the area of the data science that allows us to get, this area gives us the methodologies and the methods to find what the patterns are from the data in order to train the models that resolve a problem or can give a business value. To get information from the different cyber threats, like a malware, for example, a Trojan, a virus, among others, two approaches exist. One is a static analysis that is based on reverse engineering tools that use, or idea is to analyze where is the malicious thing of a malware or a software, analyzing the code. On the other hand, we have the dynamic analysis, which idea is to understand the behavior of the software when it is executing. These two approaches allow us to get information that we will use for the train of our models. Some of our results are available in one open book that is in Spanish. We wrote this in 2018, and you can see this that is published right now. We are right now writing our second edition in this book, and the idea is to publish at the end of this year. You can find in the second edition some of our last results. For example, we explore machine learning models to detect malicious websites using some information from the network and information from the front end of a web application. We propose machine learning models to detect cyber web attacks, for example, SQL injection and cross-site scripting. 1 year ago, we had a project for a company that allowed us to explore some information from its security operations center, specifically a technology that it is in a Splunk cloud. And we explored some machine learning defensive models that use the data from it. And the idea was to propose some of them that can be deployed in a Microsoft Azure cloud. 2 years ago, we started to explore the security in AI in order to understand the 360 degrees of the security. So we started with this question: what is about of the security of AI? We began with the frameworks and the methodology that exists for data science or data mining. And we can mention, for example, ChrisDN and Assume. We saw that these methodologies explain or introduce the privacy, the anonymity, some of the methodologies that we need to apply in our data lifecycle. But they don't mention how we can reinforce a model that is the final result of these things. A model is a software, and this need to be reinforced in order to face the challenges that can be presented when a software is in a production system. And one of them is the security. A software needs to have the capacities to face the challenges specifically when you need to face an adversarial thing. In this case, a cyber criminal. Moreover, we can mention another things. For example, the use of artificial intelligence to make non-real things. One of these is deepfakes. Deepfakes is the definition to use deep learning to make non-real things. One of our results explore the mechanisms to detect deepfakes in audio and in video. And we started 2 years ago in this sub area of the cybersecurity because we believe that the use of deepfakes can be used for the different methodologies or can be used for social engineering. So let's imagine using an artificial intelligence that can make some things that are not real. For example, in a video conference or something like that. Some of the use of the deepfakes are based on generative adversarial networks. And the results that we have right now worldwide represents some of the things that can face a person that can maybe a person subject that is real or not. In Colombia, we have right now some of frameworks in big data and artificial intelligence that allow us to some of the practices to develop artificial intelligence solutions on public and private institutions. I would like to cite, for example, the 3,920 compass that is in Colombia to develop machine learning models. Other open source things that we can find, and they are in Python, is for privacy or to give the model capacities or the data that have the capacities to be private and to give the anonymity of our systems. They're based, for example, in a methodology that use differential privacy. And one of the recognized open source frameworks is OpenMind. Furthermore, we can mention the unfairness of the models. Nowadays, there is a discussion about the model's deployment and the massive surveillance system that I mentioned previously. We explored in 2020 a model to predict crimes in Bogota, and we explore some mechanisms to reinforce the unfairness of the models that using some methodologies, and this paper was published, and if you can email me if you need this paper maybe in the future. We can find other works that I think is important. For example, the use of artificial intelligence to make malware. We can find right now some challenges from the best technology companies like Facebook. In other important conferences that have some groups that integrate the cybersecurity and data science. We can mention some of the recognized cybersecurity certifications that mention the use of artificial intelligence, especially machine learning, and some of the big tech technologies that integrate in its red teams or hackers teams the capacities of proof artificial intelligence programs. Well, this is a brief introduction of some of the results that we can find right now. I would like to introduce Jhoan Steven with his topic. Thanks.
Hi, everyone. Thanks for having us. It's very exciting to be here today. And this is an exciting day because we are at PyCon, right? So, okay, let's talk about a little bit about adversarial machine learning, the topic that we have been researching for a little bit. Okay, let's see. We have an image of a stop sign, and this stop sign, you know, the artificial neural network is able to classify it as a stop sign. But if we apply an adversarial noise, let's say a filter, or we make a convolution on the image, we see now that's misclassified as as a yield sign, right? So let's talk about that. This is another example that we have here, a stop sign, and we put like some adversarial stickers, as they call in the papers. It can be classified as a speed limit. So this is very dangerous because we are in a world that is constantly changing. So in this case, if we are using autonomous vehicles, we have to make sure that they have security in their models, because that can be used as a terrorist attack or something. Like, you know, it can be put some stickers on stop signs and make the car go without stopping, you know, can make accidents. Another example that is very particular is the email. So let's say if you find some emails inside your spam folder, it's because of a machine learning algorithm. And we see that, for example, this is a linear model, and we have two vectors, one vector which is a dictionary of words, and the other vector which has very different points. So if we can like match these words with those points, we can build a function that decides whether or not this email is a spam or not. So we see, for example, that how can cyber attack can like make the model be misclassified is, for example, we can replace letters with word with numbers. For example, we see start and bang, and this is like we can read it, you know, but the machine can't. So in this case, it doesn't detect the word, and it misclassifies it as ham, but it's actually a spam. This is another example of adversarial machine learning. Another one is very interesting because we have been using at least once these virtual assistants like Siri, Amazon Alexa, Google Assistant, and every time we make a request, we, for example, can, you know, open doors or turn on lights, etc. And in this case, we can apply an adversarial noise to the voice or an audio, and we can completely change the meaning of the whole phrase. So let's say, for example, we are in an environment, you know, like a social meeting, and then somebody puts music, and I can like put some adversarial noise to that music and make requests. So to somebody's phone to send me an email or send me some private information. So this is really important to keep in mind. So as a short introduction, that was adversarial machine learning. If we can go ahead and formalize a little bit the concept, you know, the machine learning system is M, and the input value C, which we see here, is classified as true, but we can build an adversarial input called A that is perceptually indistinguishable from C, and MA is different from true. So basically, there are malicious inputs designed to fool machine learning models. So there are three main types of attack. We see here white box. That is when this cyber attack is knows the training data, the attackers knows the training data, features of the training data, and also the learning algorithm. This is the easiest attack because we know everything. For example, we have gray box that at least two are known. Maybe we know the training data, maybe we know the learning algorithm, but the feature we don't know. Or the black box, which we don't know any of them. This is the hardest attack. So basically, with this knowledge, we can have evasion attacks, which is based on white box attacks. So in this case, we know all of three. And what we do is that we manipulate the input data in test stage. So until it performs a wrong classification. So we see, for example, an instance X that we can like shift it to the right or to the left and make it misclassified as another class, another category. And that's why we learn a lot of math in engineering, to help us build those systems. And yeah, like this is actually behind all of this is an optimization problem that's important. For example, we can use and see that and with algorithms of optimization like gradient descent. We also have poisoning attacks. Those poisoning attacks are also thought to be white box attacks because the adversarial or the attacker has the training data, has access to the training data, and he can inject some malicious data points. Let's say, for example, we have green and orange class, and at first it puts like a decision boundary between them. Let's say this is a support vector machines or something, and then if the attacker has access to the database or to the data set, he can put a red point here. For example, this is the adversarial point, and then when the machine learning model is training, we can see that the decision boundary just shifted a little bit, and you say this is creating a gap. So this is a gap, and then in future classifications it can be full because of this gap that you say here a little bit shifted. If you ask, for example, why is machine learning vulnerable, that's because most of the machine learning algorithms have an assumption, and that assumption is that the training set and the evaluation set are both of them are sampled from the same probability distribution. And this probability distribution coming back to the theory is called IDD, which is independent and identically distributed variables. We see, for example, some equations here that say that two events are statistically independent of each other. So let's say, for example, if you take a coin and you toss it, and if you calculate the probability of landing tails or head, it doesn't depend on the previous experiment. It's completely independent. So what happens with that? The attackers use this assumption to change this distribution of data. So in the future, the model misclassifies the information, so they can like seize that and attack the system. But how can we have a secure learning approach? Well, basically, we need to implement something called secure learning, and that is when a machine learning model performs well under adversarial conditions or adversarial attacks. So let's say, for example, this little comic that I like very much that has like this little balloon here that says my robust model, and then it comes an adversarial attack, and then it doesn't happen anything. So like we can do that by utilizing, for example, a framework that was proposed by Professor Battista Biggio, Giorgio Fumera, and Fabio Rolli from the University of Calgary, that they propose an interesting framework to make the model more secure. So, for example, what we have to do is, like Professor Christian said before, we have to think about our enemy. Let's say, okay, if I were an attacker, how can I attack the model? So we just put this mindset and we simulate the attack, and then we evaluate that attack, and then we can develop a countermeasure against our own attack. Yeah. So in this case, we have been published some work about classifying Android malware. We have a model. Our best model was a random forest, which an accuracy of 0.88 and a cap of 0.75. And we actually tuned it a little bit. We made hyperparameter optimization. We made it the best model we can have. But then how can we make it more secure? Actually, we used reinforcement learning, that it's a promising branch of machine learning that the previous speaker was talking about. This is really interesting. So what we do is we set as a couple of actions. Let's say R8 to R6, which is the features that we use to classify, and we have rewards +2 when it misclassifies an input and 0 when it doesn't. And we have applied perturbations. So how does it work? We apply perturbations through all of these characteristics of the benign of the malware data points, and then we apply this perturbation. And when we ask the random forest to classify it, and if this misclassifies, we receive an award. If it doesn't misclassify, we receive no award, so 0. In this case, because reinforcement learning algorithm is a greedy algorithm, he always wants to look for the best reward. So he actually makes some changes, some perturbations, and then in this case, we do it until we can transform. So what we have to do here to improve this is to do adversarial training, which I like to introduce as Bootsy never made a skilled sailor, because we have to put some hard data points for it to able to train. So we did this in this framework. I invite you to see the documentation. That is really interesting. At the end, from recognizing 0 adversarial points, we recognize up to 71% of the adversarial evaluation data, and it's possible to perform adversarial attack using reinforcement learning. And after adversarial training, the model maintains its good performance in classification. And for future work, we want to improve the reinforcement learning algorithm to perform more accurate perturbations and propose a programming method to perform an attack on a machine learning model with black box approach, because we made a white box approach, and that's pretty easy. But to make the black box, it's very hard. So we want to work on it. That's what will be very interesting. And we would like to explore deep reinforcement learning and GANs proposed by Ian Goodfellow, because these are deep learning, and they are very precise when it comes to perturbation. So it makes it hard to recognize. So that's like the whole point. Thank you very much for all your attention. This is the GitHub repo. If you want to go and see the code, it's very interesting. And I don't know if you have any questions. Thank you very much for all your time. And I'm really happy to be here with all of you.
Okay, thank you so much for your talk. This was a really interesting topic. Normally, when we talk about machine learning, it's just for models and for, I don't know, trainings and that kind of stuff. But talk about hacking and another security aspects is really, really interesting. Thank you so much for your time. Thank you for your talk. We have a little time before go for lunch. It's important take a good lunch for the second part of the day in the conference. So we have a couple of questions. First one is, what is the correct approach to process PAA in order to train use an artificial intelligence model?
Can you repeat the question again? I didn't understand it very well.
What is the correct approach to process PAA in order train use an artificial intelligence model?
I don't understand it very well. I don't know if Christian can answer, because I don't know what it means. What do you mean by PAA?
I don't know. That is for Jesus Cruz. Maybe if Jesus can make a little more detail, it will be useful.
Okay, I can
Another.
answer both.
Okay.
Can you hear me? Well, as we explained, independently, if you are analyzing a cyber threat, the best way is to use some of the two approaches. One, the static analysis. If you have the code or the application, the idea is to analyze the code, because you will get some of the features that you will use for the modeling, for the broader activity. If you have the capacities to emulate the infrastructure, you can use and you can get the information when the cyber threat is using both data sets. You can have all information, well, a part of the information that you can use or you will use in the next activities. If you know, data science is a life cycle that repeats again and again and again. It is a scientist approach. But the best idea, if you are analyzing a cyber threat, my recommendation is, we mentioned, static analysis and dynamic analysis in order to see some of the features.
Sorry. Another question also from Jesus is, Splunk is a good SAM tool, but what is the main highlight in order to improve security to your models in a preventive way instead reactive way?
That is a good one. But the idea is you can have in the cybersecurity, you have different layers. The idea is to have another one that is going to be another layer that can see the things that maybe other layers, for example, the firewall, the anti-malware systems, that can see. But the idea is to win another layer to provide some things that are more an adaptation from the data. Yeah, but because when you have, for example, one attack 0 days, or I don't know, yeah, more advanced attacks. These kind of firms or signatures or databases from the big companies is not possible to see everything. But you have the data. You can have your personalized models that can predict the things that are anomaly. Splunk is a big data set, a big data set. So moreover, Splunk has some of the capacities in machine learning. But one of the things that maybe is important here is that a data scientist that knows about cybersecurity data scientist can see more things that maybe happened in a pen testing or an attack that maybe another data scientist that doesn't know about the business that happens in other areas can see.
Okay, thank you. A couple of questions more, and we can go for lunch. And a good lunch, please. We need energy for the afternoon. Um, at what level should deep fake algorithm is capable of sheet of face recognition and licenses system?
I don't know if Johan wants to answer or me.
Can you repeat the question, please? I don't understand.
At what level should deep fake algorithm is capable of sheet of face recognition and licenses system?
Well, I think this goes to Christian because I'm not that expert in deepfakes. Yeah.
Okay, don't worry. Well, I saw different works in deepfakes, as I mentioned, in audio or video. I think one of the last results is the integration of both, because in in a engineering, on social engineering attacks, the idea is to convince someone. So you can combine different dimensions in order to convince someone to do something that they don't want to do. So in defects, you can make non-real things, and we have a lot of that advanced or different or good results in this. I think that maybe one way in order to face these kind of challenges is we have been trying to explore the use of deep learning using convolutional neural networks with some long-term memories. The idea is to analyze, for example, some noise, some things that is happening, for example, in the we are working right now in sound specifically, but I think that the integration of different dimensions for independently, if you are using one model or complex model, is an interesting area to generate novel things. For example, you can use the environment or something like that. The idea is to convince someone.
Yeah, sure. Okay, thank you. Last question. Sadly, we don't have more time, but remember you have Slack and we have Gator Town to interact. Please get inside on Gator Town, go to the stands, go to the different spaces, and you can not just make the question for Slack in Gator Town. You can share with your camera and maybe make some interchange for ideas. Okay. Last question. Is there a way to protect federated learning models from malicious attacks?
I think so. I think it is possible because federated learning is a one way in order to train some different machine learning models and to integrate the privacy of the data. As Jhoan mentioned it previously in his presentation, we proposed a framework that can be included in the data science processes. The idea is to think. It is my final conclusion. My final conclusion is the idea is to see to think like a ethical hacker. Yeah, the idea is to see like an ethical hacker and to create environments that maybe see through the process of data science. And this data that maybe could be noise or could be not, the idea is to recreate artificial environments that you don't have. So, good to the point. Federated learning is one way to provide privacy, but we can have another framework in order to reinforce the model before to go to production system or during the production system.
And to complement a little
Okay.
bit about the Christian's answer, I would like to say also that it's very interesting to see, and I invite you to read the work of Professor Batista Billo of the University of Calgary, because he has been working with this since the very beginnings, one of the pioneers of this topic. And also it's very interesting because he actually unveiled this framework and also a Python library to be able to train and securely the model and also the environment when it's put to production.
I would like to mention something in final. You can all the results that we presented is in Python. thanks to the community in Python. All the frameworks, all the projects are in Python in the GitHub that Jhoan showed previously. And we can have, if you have any questions, you could write us. We have an open source project in Python that other universities has been working on, and that's it. I think so.
Okay, thank you so much
Yeah.
for be part of the PyCon Colombia conference in this 5th edition. Thank you so much for all the attendance, for all the speakers before you. And now it's time for lunch. So we will come back in more or less 1 hour. So we invite you to see the schedule, select the talk that you prefer, and see you later. Thanks so much.
Thanks,
See you. Thanks.
everyone.